All right, we're gonna move on to the next thing. Okay, SageMaker. I'm going to tell you that pretty much all the questions on the exam were all about SageMaker. Don't get me wrong. There were questions like, how to use mice and, gradient descent. And so, like, there was all the standard questions that you would expect in standard machine learning kind of conversations, questions on data augmentation. I don't know that there was like a really interesting question about scikit-learning, like what's the name of the standard scaler? I was like shocked at some of the details of those questions. But for the most part, it was mainly about SageMaker. How do you use SageMaker? How do you deploy SageMaker? Other adjunctive services like ground truth and A to I, but not a whole lot of questions. There was like one question on ground truth, maybe two questions where the answer was in there, and then one question on A to I. So just know the bulk of it's either about models in ML and how to manage them, or it's about like this service. So yeah, this is the bulk of it. And luckily this is where we're going to spend most of our time, right? We're not going to even really touch ground truth. We're not going to mess with anything else. We're going to be basically manipulating notebook instances inside of SageMaker, which is probably the bulk of it. Dun, 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 dun. Oh, I have a demo. Oh, luckily I'm ready for that. Did I sound surprised? I didn't. All right, so here we are. We've got a fully managed service basically that's used to build, train, and deploy ML models at scale. It used to be a little confusing because SageMaker, I want to say, came out in like 2018. They also had an ML service, but I don't think they're accepting any new customers on the ML service. A little bit of crossover there for a while. I'm not sure what to think of that. I haven't really talked to Amazon to figure out, AWS to figure out what they're doing with that. But here's where SageMaker fits, right? SageMaker fits on everything that you want to do that involves like basically modeling and the execution and ingestion and all that of the model, right? Between S3 or EFS or FSX, which are basically three storage services. And if I said those really fast, you're like, Michael, what are you talking about? Don't worry, we're going to talk about them. Everything else just fits within the side of the SageMaker rubric. You basically have dedicated machine learning virtual machines, although if I remember correctly, they only charge you for the training time. I don't think they charge you for the running or hosting of the virtual machine, right? But if you were to do this manually, like I have done so many machine learning workflows manually. And when this came out and started like getting really robust, especially in 2019, 2020, this was a game changer. So we are going to be working in Jupyter notebooks, right? This is, by the way, we're going to allow you to code and report and perform data visualizations. If you're working in machine learning, like this, Jupyter notebooks really changed the landscape, right? So they're really just interfaces that provide like kind of pre-built and optimized components just for like working in your notebooks. By the way, you can run these notebooks on your local laptop. People do it all the time. You may not get the same performance that you would if you were running on a big honking ML system out on AWS, but you can, and it's certainly useful for exploration and training other data sets. So we're basically going to be using Jupyter with SageMaker ML instances with their own, the kind of standard algos that go inside SageMaker. And we're going to talk about what the general algorithms are, because you will be tested on that as well. So where does all this live, by the way? Okay. You'll be like, you know what? I'm a data engineer, Jim. I'm not a doctor, right? I'm not a DevOps guy. What do I need to know this? Well, just in general, know that, if you're just going to be messing around with notebooks and you just want to like do a proof of concept, what Amazon kind of expects you to know is that there are general classes of like virtual machines that you can use that are optimized for different things. The T series is, from my perspective, is really the test series. So the T series is like the T2, the T3. These are like designed virtual machines that have certain characteristics to them. So like the T family is really cheap and won't give you like 100% of a full processor all the time unless you go really up on which you buy something called CPU credits, but they're great for proof of concepts and just messing around. So if you want to run one in your own account, like a T2 or a T3, Amazon will actually give you one for free if your AWS account was created in the last year. Now, the rest of these, the M family, the R family, and the C family, I want you to ignore the P and the G family for a second. The M family, R family, and C family are basically virtual machines that have been designed around an internal component. Let me give you an example. The C series has better processors than the other two because it's a compute optimized instance. The R series has more RAM than the other instances because it's the R instances, right? So meaning its ratio of memory to processor is much higher. The M series is the median series. This is just your general purpose kind of average workload here. The M family just has a standard kind of CPU to memory ratio and just kind of an average system. What's the standard? 4-to-1, meaning you got 4 processors and you got 16 gigs of RAM. Just standard, right? So the ratios between the M, the R, and the C series change based on whether it's a C series for compute, an R series for RAM, or an M series for median. I know it's weird because you're like, but doesn't M mean memory, Michael? No, it means average. Median, right? So those families, just be aware for those purposes. Now the P's and the G families of instances, those actually have, in many cases, they have like tensor, like GPUs on them, right? So they're great for, training and inference because GPUs, right? I know this sounds weird, but GPUs are better than CPUs at certain types of mathematical computations, and they go faster. And you can stack up a bunch of them, right? Inference, right? But Chris, we're going to leave that there for a second, but think of it just as prediction, right? We're going to explain that better, but just think of that as prediction for the time being. Okay. So the P family and G family are what they call accelerated compute family. This is the accelerated family. So different from the C family and the R family and the M family. P and G actually go together. They're part of the GPU accelerated computing family. They have video cores, GPUs inside of them. Now, elastic inference is interesting because elastic inferences basically allows you to attach GPUs to any of these systems and get an amazing amount of horsepower out of these boxes by attaching an elastic inference to it. It is one of the cheapest ways, by the way, to take a low-cost instance and add a bunch of GPU horsepower to it, which is kind of a simple way to say that, but it basically adds inferencing like GPU level horsepower to it, so you can make inferences easier, predictions easier. Chris, to clarify that, inferencing refers to when you use the model to basically make predictions in production, right? So it's really fairly synonymous with predictions. It's just like it happens in production. So yeah, so that inferencing, elastic inference, by the way, can it be added to almost all the types? I don't think the T family can handle it, but I have to look that up because I could be misremembering that. But you basically add inferencing capacity to any of these systems. Okay. So one of the things you have to determine when you go to start a SageMaker notebook training instance, right? Because you're gonna run a notebook. You have to choose the size. Now, note that within these families, by the way, there's usually like a small, a medium, a large, an extra large, a 2x large, like there's like, it's t-shirt sized within the family. Note that all of these, by the way, just to make it super confusing, they all have a generation number. So like the higher the number, it's the newer the like system. Let me give you a website that's gonna really help you with this. All right, this website is called, I like to call it ec2instances.info. That's actually the old name because someone bought this open source project recently. I don't know why there's the thing at the end. Did I do that? I must have done that. Anyway, it redirects now to instances.vantage.sh. For some reason, I can just remember ec2 instances.info. I don't know why. I can't remember instances.vantage.sh. It's probably just because I've been doing it for so long. So notice that this is just a generic website that scrapes Amazon's API to find out which machine types are available. Now notice there's an EC2 tab, which actually, let me just put you right here because you're kind of in my way. Notice that there's an EC2 tab right here, and then there's an RDS tab. There isn't an ML tab, and I wish there was, honestly, an ML tab, but there isn't an ML tab. So, but for example, in our lab, I believe that we're using what's called an M4, and it's actually called an ML.M4, but they don't have ML instances, so it's M4.xlarge. That's a 4 CPU, 16 gigabyte system, right? So notice that that's going to cost you about, on demand, it's going to cost you about 20 cents an hour. Where does it say that? It shows it right here. And I'm not going to get in reserved and minimum like spot, cost, because that's a whole different discussion. It's assumed that you know, by the way, that spot instances are the cheapest, but the most prone to interruption, and that reservations are you getting into a 1 or 3 year contract with AWS. Don't worry, if you don't have that knowledge, I promise it will become clear when we do the study sheet. When we look at the practice exam, you will know exactly what you need to know, okay? Now, if you come in here and you're like, Michael, I don't think a 4x large is going to cut it. Can I get a bigger size? Notice there's a 2x large, a 4x large, or whatever. Now, I want to tell you the M4 series is a little long in the tooth. It's been around for a while. If I go to M5, there's an updated model. If I go to M6, is there an updated model? Not the kind I'm looking for. In general, when you're in the SageMaker console, it's not going to list you the instances that you have access to. Just know that the higher the number, typically the cheaper for the performance the instance is going to be, or really just cheaper in general. So just know that you generally want to use the latest number. Now you might say, but Michael, you seem to be avoiding the M6s for some reason. The only reason I'm doing that is because the M6G is an ARM-based processor. Unless my tooling is built for ARM, I'm not going to do that. But I could use an AMD processor. I don't think they have an I. Do they have an I? Oh yeah, they have an I. I could use an Intel-based processor. Do I really care about AMD versus Intel? I mean, not really. Unless I'm just looking to squeeze out the juice and the performance somewhere. Anyway, the other thing is they used to show GPUs, but I don't see that here anymore. Anyway, bottom line is that if you're looking for characteristics just based on processor and memory, you could go here and look. You can also, by the way, go to EC2 instance types. And typically the instance types, barring the ads on Google, right? You can see the general purpose, which is going to be the T series, which is, I think, is test, but they sometimes refer to as general purpose. Here's the M series for median for average. This is the one that has the 4:1 ratio. Compute optimized, which has the C's, right? And by the way, don't ask me what these letters are afterwards. I know you just saw me explain them. I have to look them up too. Amazon has gone crazy at expounding on the flavors and varieties of virtual machines they offer, which is cool in some ways, but it's a little bit like the buffet. Like if you ever go to like a good, like, I don't know, Asian buffet, you're like, I only really want 7 things off this thing. I don't want 20, right? And then here's the memory optimized instances. These were the R's that I was talking about earlier. The accelerator are the P's and the G's. This is what we were just looking at the slides. And then most storage optimized isn't really used a whole lot. I mean, you might use it for some kind of data warehousing, but quite frankly, S3 is so good at data lakes and as a data source, even with data warehousing, actually, that people just use S3 for that. So to link this back, this is what we were just looking at. When you pick your virtual machine size, you might need to know some characteristics about that. So that you might see in the console that you can choose like an M4X large. If you want to use this website to go back, this ec2instances.info, you can type M4X large and you can see it. You can also just go to the documentation, but this is a really quick way for you to see the size of that virtual machine that you're running Jupyter and Python on. Okay. All right. And remember, elastic inference allows you to relatively cheaply actually add inferencing or prediction power to your any of these instances, I think, except for the T family. But that was me making that up. My memory is not always the most perfect thing, especially with a head cold. So, okay. Are we good with this? Have most of you seen this before, or is this new information for a lot of you? By the way, that reminds me, I was going to post this link up there. Okay. Karita. Wow. I am so glad that you have very clear goals that you're shooting for. That's awesome. I think that we are going to talk about all of that actually. Just correction model, loss functions and weight, X boot, G boost. Yeah. Standard deviation. I think we're going to talk about all of that actually. I'm pretty certain. If we don't, let me know. We'll talk about it outside of that. So AWS 101 covers this well. Ignore it. No, that's good, Karita. I like it. Worked with some of this before, but explains the instances. Sorry for the typo. Nah, no worries. That was gorgeous. It was awesome. Cool. All right. Good. So just remember, you can look this up. But you don't have to remember that. Just remember that the T series is for test, M is for median, R is for RAM, C is for compute, P and G are accelerated computing, and that elastic inference will allow you to relatively cheaply add inferencing like GPU power to any of those instances, I think, except for the T's. Cool. Okay. I want to show you this really quick in the console because I just want to explain this. Maybe some of you haven't seen this. Oh, look at this. There's an instance right here. Oh, that's right, because I was going to show you. I had my demo, right? One thing I want you to know. So I'm in the management console right now. Hopefully you've all seen this in some form or fashion. Ooh. You all are working out of GovCloud, are you not? Please confirm that for me. I think if I remember correctly, Boost works pretty exclusively out of GovCloud. Is that correct? Yeah. I don't know that how many of you have access to private sector systems. I think most of you are working in GovCloud. So I'm going to check on something for tomorrow. Just yeah, I hear you, Jonathan. So here's what I want you to note. We're in SageMaker right now. SageMaker has 1, 2, 3, 4, 5, 6, 7 subservices underneath it. Okay. So we are mainly going to be working under notebooks instances here, but I'm going to just mention a few other things. But just know that when you see them say, hey, you want to use like notebook instances or you want to use ground truth or whatever, they're still talking about SageMaker, but they're talking about services that are like subservices underneath SageMaker. Okay. So just want to make sure that you saw that is that there's, SageMaker inference, there's SageMaker training, like they are primarily used for like different things. Most of these, by the way, link back to notebooks. I know that sounds strange, but when you are doing a hyperparameter tuning job, you can call that job within the notebook, right? So anyway, we'll come back to that, but you can create all of this programmatically. You don't have to use the web console at all. But I will tell you from like most of us, unless I'm doing DevOpsy stuff versus MLOpsy stuff. God, even with ML DevOpsy stuff, I actually never really go in the console. If I'm doing MLOpsy stuff, I'm generally going to be in the console because especially if I want to show someone how to do something, it's easier to visualize. But if I just want them to execute some code and repeat it, I'll either give them CloudFormation, Terraform, or some variation thereof and have them just set up their machines. But most of the time when we're interacting, it's going to be very visual because it needs to be because there's visualizations, right? But I just want you to know that there are some subservices here. And so if you hear someone referring to like, A to I, which is augmented AI, or the marketplace, they're talking about subservices underneath SageMaker. So make sure that's clear. Hold on just 1 second. Okay. Making sure one of my timers didn't die. All right, so I just wanted you to see that. So we'll come back to that. Okay, so then when I say SageMaker ground truth, I am talking about a subservice under SageMaker, under the SageMaker macro, right? Because you just saw there were a bunch of services on the left-hand side. So ground truth, by the way, allows you basically to create, if you want, like your own kind of like jobs, right? So you're ready to process your data. And you think about our conversation about supervised learning. And so you need labeled data, but labeling data can be like tedious and, but you need a workable data set, right? So after you've collected your data and prepared your data, but maybe you're missing labels, you can actually use SageMaker ground truth because it will provide access to teams of human labelers who will label your data, which you can then feed back to your service for automatic labeling, right? We can use ML to learn the label in the same way that the humans did, right? So SageMaker ground truth, by the way, you can either provide your own private workforce, you can buy a third party through the marketplace, their labeling workforce, or you can use what's called Mechanical Turk. And Karita kind of beat me to it, right? Mechanical Turk, by the way, is, so there's three kind of underlying ways you can execute ground truth. Mechanical Turk is just like Amazon's like human army of people that will label data, right, to that like 95% of accuracy that you saw earlier, right? Mechanical Turk, that data will be shared among the public. So as you can imagine, some people don't like that from a security perspective, depending on the nature of the data that's being evaluated. You can create your own private workforce and have the data routed to them in a certain way and have them interact and label it. Or you can get a third party that can get under NDA and all other kinds of security contracts that you can actually have label your data as well. Okay. So if the data is sensitive, I don't really find a whole lot of people approaching it this way. They'll go to unsupervised learning to try and label the data or get some kind of pieces on it. Or they'll have internal like employees, like a call center or something, kind of like go through and label the data. So just know that ground truth is here, right? So after you set up your notebook, by the way, so you've chosen your machine size and you got it all set up in the security groups and all that stuff. Yeah, so Mechanical Turk, the private workforce, and then the third party workforce that you can get from the Amazon marketplace, those are all ways in which you can denote how the data gets labeled. So Chris, does it get labeled by your own private workforce? Does it get labeled by a third party in the Amazon, the AWS marketplace? Or was it done by the Mechanical Turk public workforce? So as you can imagine, going from public to third party to private, your data could be more securely controlled because obviously if it's your own private workforce, you get to, in a sense, control the exposure. Yeah. Okay, so you set up your notebook, you got your data in it, you want to see the data visually, right? Large amounts of data are much easier for the brain to process visually in terms of like pattern recognition. This, by the way, can all be done inside of your Jupyter notebook. You're going to see this. And so, and you're going to get to do this for your projects. So you can visualize your data, which will help you select the features you actually want to use when you go to build your model. So like sifting through all the data to find patterns and associate meaning takes time, but obviously, to find a pattern is to a certain degree the first step in finding a solution. So visualizations can really help you find and see those patterns. Like, obviously there's a histogram, there's a cross correlation of variables, scatter plots, right? So along those same lines, oh yeah, there's a ton of algorithm options. So after you've explored and analyzed your data, and so you've done all the pre-processing, you've collected all that, you're ready to build a model. Now, building a model involves a couple of key components. There's your training data and your algorithm, right? So one of the reasons we're using SageMaker is that, it has algorithms already built into it, so you don't have to write or configure the algorithms. Let's be clear. You can use the built-in algorithms. You can also write a script in a supported framework like PyTorch or MXNet or whatever. You can also use an algorithm you can subscribe to an algorithm from the marketplace, just like you can get a workforce from the AWS marketplace, like a third party. You can also get algorithms from third parties. You can also bring your own algorithm if you want to. Now, I want you to know this, and I'm going to say this because this is on the exam. At least it was on my exam. You cannot edit the algorithms that are inside of SageMaker. That doesn't mean that can't change the inputs and the outputs and all that stuff. But you can't change the algorithms. If you want to change the algorithm, you need to bring your own algorithm, right? Just so you know. And by the way, SageMaker works off of this concept of containers, which is like process virtualization. So you can actually build your own Docker container, shove it into ECR, which is the Elastic Container Registry, and SageMaker can consume it and process your data based on the containers you create. So that's a little beyond the scope of this class, but I want to make sure that you understand that because that also shows up occasionally on the exam. One, you can't change the custom algorithms. You got to bring your own. If you do want to bring your own job, by the way, your own algorithm, you're going to need to put it into a container, and that container is going to end up inside the SageMaker instance. So if you didn't note that, probably a good idea to do so. Okay, so let's see. Let's say you build your own model. So you trained your model and you're ready to improve it or tune it, right? Because you're in the feature engineering kind of model tuning part. SageMaker does this thing, by the way, called automatic tuning. By the way, I'm assuming some of you have used SageMaker before and you've done hyperparameter tuning or also automatic tuning. Is that correct? Cool. I love that. Not one of you. That's perfect. I was certain that somebody was sitting out there going, yeah, I've seen this before. Anyway, model tuning can be done automatically. In other words, you can actually have SageMaker run through most of the permutations without you can just have it figure out which parameters are going to optimize your model. It's called hyperparameter tuning, and it basically just adjusts and tweaks your algorithm. And so we're going to talk about that, but SageMaker has a ton of useful features that allow for model training and tuning, and it'll do a lot of it for you. Now, you can customize that to a certain extent, but it's kind of nice to have it run through all the permutations. If it has an algo in it, Devin, it's going to be bring your own, right? Now, if you're running a custom, if you're modifying, running your own build or startup script, right? It's, I know it's funny because in the Jupyter notebook, you could actually run an algorithm. You can call the algorithms that you want. But in general, if you want that to deploy into production, right, as part of your model and use that algorithm, you're going to have to basically code it yourself into a container and bring it over. Most of what you're going to be running as part of your scripting model is going to just be changing inputs and outputs, right? So you wouldn't execute the notebook obviously is used for setting up and training and all those other pieces. Once your model is trained, the algorithm that's going to use is going to be determined by what you call with the SageMaker job. So you could call your algorithm as part of your kind of evaluation and pre-processing process, but when you actually invoke SageMaker, you have to declare the algorithm you're going to use. If you want to use something custom at that point in time, you have to provide your own container. But when you're actually in the notebook, you can call whatever code you want to. So, but if you I want to use this, what I refer to sometimes as skillet learn. If you want to use skillet algos, right, you'll have to write your own container for that. Hope that's clear. Okay. This definitely shows up on the exam. If you just want to in real time submit, I want you to make a prediction based on data. Can't edit the SageMaker algos, but how much visibility? Hold on one second. How much visibility into the algorithms is there? It's in the documentation. Obviously, you can see them, right? Joel, wait till we get to that point, and if it's not clear as to what they're doing, we'll peel it back more. So you can deploy one of two ways. You can do it online, which allows you basically to, change the parameters at time of submission and say, hey, give me back a reference. You can also just say, I just want to kick this whole data set, right? Their first way allows you to get like one prediction at a time in real time as you submit it. Second way allows you to get predictions on an entire data set. We'll talk about this more when we get into like the productionizing phase of our projects. Just keep in mind that once you've deployed your SageMaker model, there are several features to help you manage resources and continue optimizing, right, as you submit. By the way, you can also mix and match like different versions of your model. You can do like, you could have like 3 or 4 different versions of your model and call the one at the time it happens. Some people will put it like an API gateway or a Lambda function in front of their, like a proxy, almost like a load balancer, but not really, to kind of like take the request and then call the model that they're looking for. So there's a couple cool things like that you can do. All right, let's put this into practice. Okay. So is this lab still up and running? Let's see here. Let's see, this is the one we were looking at earlier. I think I opened this up. By the way, someone tell me who knows, because I think I know, but I always like to test it. What is the difference between opening a Jupyter notebook and open up Jupyter Lab? Has anyone ever done this before, by the way? When you ever use Jupyter Lab, what's the difference? No? Okay. Notice, by the way, this is an M4 extra large. So just to answer this, because some people ask me this question, when you open a Jupyter notebook, this is the typical notebook that you're kind of used to seeing. And what this does is this is going to open up the standard interface, right? Where you get to open an IPYMB file, like a notebook file. And this is actually from like the data preprocessing lab, which I think you're going to either see today or tomorrow, probably tomorrow. And what this does is that when you open up these files, it basically converts all the markdown into text and then allows you to run code as you kind of like run down the notebook, right? But this viewpoint is kind of like how it opens up. And that doesn't look like an IDE, it just looks like a file system, right? Just looks like we're looking at a directory. If I come over here and open Jupyter Lab has a way of comparison, what's going to happen is that this is going to look a little bit more like an IDE. And when you open the notebooks, instead of opening it to a separate tab, it's going to kind of open it within that same tab. So you can interact from it from kind of one interface. Now, a lot of people just use their favorite IDE of choice to do this, right? But like here, for example, if I open up the, where's the English version? Here it is. It just opens it up in another tab, right? If I go over here and open the cheat sheet, it just opens it up in another tab. So that's really the difference, is just the interface between Jupyter Lab and Jupyter. What we're going to be doing mainly is just going to happen in Jupyter, but I just wanted you to know what Jupyter Lab does. It just provides you like this more kind of IDE level interface. Okay. So here's the standard Jupyter notebook, and notice it has Jupyter Lab in the upper right-hand side. So I already opened, like, for example, the Python cheat sheet. Now this is a little bit of an eye chart, so I'm going to blow it up greatly. Which is probably what I should have done to begin with. Yeah, there we go. Good. Let's shrink that down just slightly. So this, by the way, is now running on the ML M4 extra large, right? This endpoint's already here, but that wasn't the demo. Just to come back, the demo was to create a notebook instance. And the reason I'm showing you this is that you're about to do this in your own lab. And I want you to really pay attention, because this will, I'm pretty much going to do it the way the lab does it, right? Now, here's a word of advice about Quick Labs labs. If you have instructions, actually, let me open up the instructions for this lab and pull over the thing. Here we go. If you have instructions, for example, like this is this lab right here, and it has a gray box like this, and it says capital ML -dev -notebook. This is a Quick Labs challenge. This is not an AWS challenge. What's happened here is that if you do not spell that exactly in the same case that they are asking you to, sometimes it will throw a security error and say you don't have permissions to create that instance because, well, frankly, you didn't name it what we told you to. So just know that sometimes the labs are super rigid about the names and the types. Like when I came in here earlier, I forgot to change the machine type to an M4 X large. I actually had it set to like a T3 X large or something. It was like, you don't have permissions to do that. I was having to go do it my own account, but then I realized that would probably be a valuable lesson for everybody. So just know that when you go through these labs, make sure you follow the directions explicitly. You're gonna have to get very detail oriented. Like if, for example, if you miss like one of the encryption steps, or sorry, not encryption, configuration steps for like a role or a VPC or whatever, if you forget to do that, a machine might not start. And then it won't let you delete it. And then it gets really weird because you can't create more than one. So just know that like you want to be meticulous about and detail oriented about when you follow the instructions. Okay. Just making sure you know that. Okay. Hold on just one second. What are you doing? Bear with me. There we go. All right. So let's say I'm going to call this ML dev test. Oh, I'm going to just make up my own name too. Why? Because I'm not really going to start this because it won't let me anyway. Notice it was set to an ML2 medium. When I come in here and change the size, by the way, you can just set it to the M4 that's specified, and you can type the whole thing out if you want to. Now notice that there's links to documentation about things like elastic inference. So for example, I could come in here and say, you know what? I want to attach some extra awesome, compute power to this. And if you want to know more, you can just click on it to like open it up in a new tab. Because one of the first labs we're going to do is you're going to explore a lot of this information, right? You're going to check this out. And actually that reminds me of something. So hold on just 1 second. Okay, good. Just want to make sure something was set. So for example, you're going to explore the documentation. You're going to come in here and take a look at, some of this information. You might not click on the documentation links, but just know that there are options here to kind of get directly to the information you need. So notice that we're not really changing anything else. If I remember correctly, I think we just leave it all alone. And then you're going to come down here. Now, notice that this is where you set permissions. And by the way, these instructions are all laid out for you. So you really do not have to remember every single detail I'm sharing with you. This is just a demo of kind of the things you have to figure out in order to launch an instance. So this is a role that defines what permissions the SageMaker instance has. And you're going to follow the directions. They're actually going to have you enter a custom role here, but I'm just going to stick with the existing role because it's actually the same thing. And then I'm going to keep root access because the instructions in your lab don't say anything about that. And then what they do say, though, is that you have to switch to a dedicated network that says ML pipeline. Everybody see where it says ML pipeline down there? Good. And then it's going to ask me to choose a subnet. Guess what that's called? ML pipeline. You're going to click on that. And then the security group, guess what that's called? It's called SageMaker. Now, please do not do what I'm doing. I'm not reading off the instructions, but there are very clear instructions. And the only reason I'm not looking at them is because there's only one option. I know exactly what, and I'm not going to be using this. This is just to show you, right? By the way, you can disable internet access if you want to, but they're not asking you to do that. Notice that I'm not tagging it. I'm not sourcing any Git repositories. It's kind of fun, by the way. You could literally have a repository cloned inside of your notebook the minute it launches. It's kind of nice, right? So that's it. I came in, named it, chose my type. I don't think I really did anything. Oh, lifecycle configuration. Yep, forgot that. ML pipeline. So don't forget these little caret boxes here. If it says click on additional configuration, that's what they want you to do. They want you to open up that little box. ML pipeline. So lifecycle configurations are basically startup scripts. They're boot scripts. They're configuration scripts. That's what these lifecycle configurations are. Let me show you that really quick because I think that's really cool to see. Is if we go back to lifecycle configurations, notice that I just chose the ML pipeline lifecycle configuration over here. So see, it's right up here. I just chose ML pipeline. If we go back in and look at this pipeline configuration, you can actually view the core script that was used to create this notebook. Notice that it's copying a bunch of scripts from the SageMaker solutions. It's copying a bunch of data, changing ownership of a bunch of folders, splitting some notebooks up. Nice. Moving solutions, it's like, it's basically configuring the system for you, right? So just know that these lifecycle configurations will allow you to spin up multiple instances that have the same configuration, which is really useful for your team, right? If they're all doing the same thing, right? So here we are, we've set up all our stuff. And then at this point, we just do create notebook instance. Now, at this point, I'd be shocked if this worked, but let's try it. It should fail. Yeah. Yeah, it's because, by the way, the name isn't correct. You know why? Because I already have one with that name, right? Which you saw earlier. So I can't create that. Matter of fact, if I take this off and try to use the same name, what was the name earlier? Let's go take a look at that. Oh, different lab. Can't do that. Anyway, but my point being is that you have to match lab instructions exactly. Just FYI. Now, let's see. Cheat sheet has changed on disk since the last time. Let's revert it and see what happens. Anyway, my point being is that you're going to be here. You're going to open up your Jupyter notebooks. You're going to run through these notebooks. This is the pre-processing lab that we're looking at right now. But these Jupyter notebooks, by the way, are going to contain things like Markdown, which, by the way, if you ever want to look at that, you can just double click on it in order to peel down the Markdown. It's going to contain code that you can actually run, right? There's a couple of different ways to do it. You can click run up here, or you can just do a shift enter if you want to. Notice that it has an asterisk next to it. It's running the code. It's running it. Probably don't want to run anything else. Let me rephrase that. You don't want to run anything else until that's done. How will you know it's done? It'll convert to a number. See how it went from an asterisk to a number? That means it ran that code. Now, if you didn't have any like print statements in there, you're not going to see what it did. It just like basically imported pandas and NumPy, and then imported some stuff from Matplotlib and Seaborn, and it set some options. That's it. And you kind of run through the rest of them, and you can, shift enter through them if you want to, right? Here, I'm going to run the other one, right? And notice that went from an asterisk to a number really quickly. Now, as I run through this, it's going to print, like, for example, if it says there's a print line here, it's going to print the number of features, right? There you go. Print the number of features. So my point to all this is that I'm not here to show you what Lab 2 looks like in detail, but you're going to create a SageMaker notebook instance, and you're going to run your Jupyter notebooks from there. Here's something really, really important. The directions will tell you to download your Jupyter notebook at the end of every lab. That's going to be file, download as, and then notebook. Save it to your local system, meaning your laptop, your desktop. Do not make a copy, because that's going to save it on this system. This system is going to go away. Your laptop and or your desktop are not going to go away. So please make sure you download a copy of your notebook file, and you're going to get warnings and instructions about that through every single thing, because if you lose it, you're going to have to recreate it. Okay. Don't worry. I'm going to remind you, it's going to be very clearly laid out in the lab instructions. I'm going to ask you at the end of every lab, can everyone give me a checkbox confirming that they have downloaded their Python notebooks? Okay. Okay. So they gave you a little precursor. Don't worry, you're going to get hands-on. You're going to see this yourself here in a bit. Okay. And that is the SageMaker notebook instance. Okay. Wasn't hard, was it? Set some permissions, set some sizing, put some location data around it, like networking and stuff like that, and you're done. Create it. It usually takes about 2 to 5 minutes to start up a SageMaker notebook. Once it's gone from a pending state to running, you'll have the links to open up your Jupyter notebook and to open up your Jupyter lab if you want to. Okay. All right. Well, let me just check this really quick. Okay. So here's what we're gonna do now is that here's our summary, right? Our summary is, what is SageMaker? Well, a fully managed service, build, train, and deploy ML models, and Amazon likes this little marketing say, at any scale, right? You can use part or some or all or none of SageMaker's features, right? Jupyter notebooks, instance types, this is what we covered. The fact that you can use ground truth to get human beings to label your data, particularly during pre-processing, and that in the Jupyter notebook, you can basically just list all your data visualizations. You can use a built-in algorithm, use a custom script in your own framework, use the marketplace for algorithms, or you can bring your own. Your deployment options relate to being either online real-time or batch, where it's going to process a large data set at one time. Any current questions about SageMaker at the level that we're currently operating at? Excellent. Okay. Now we're on to lab 1. This is a 60-minute lab. You are going to launch a SageMaker notebook instance. You're going to run a Jupyter notebook, and you're going to run code in the notebook. This is your first time probably running one of these labs. You're going to relax. Just relax your eyes. Don't panic. It's all going to work out really nicely. So first thing I want you to do, and I want you to give me a green checkbox when you get there, is I want you to go to this particular link. As we talked about before, and I want you to get logged in, and I want you to get into your classroom, and I want you to get into lab 1. Chris, I in general, I would stick with the pre-made algorithms in SageMaker. You might, if you have some kind of deviation from the standard algorithm that you want to add or customize that it can't be done in input or output, then you would like basically add your own custom algorithm. So you will very clearly know if you need an algorithm that isn't provided by SageMaker, but you want to run it in the SageMaker infrastructure. You will very clearly know when you like it's not going to meet your needs. So no, Chris, especially if you just wanted to test out a small data set. No, it's not going to be a high level of effort or cost, right? Oh, one of the labs didn't pre-warm? That's weird. Huh. I like that actually. Oh, probably someone took it. Okay, good. That's good. All right. All right. So here's what I want you to do is I want you to open the lab, and mine's already open. So I already opened mine. I want you to go ahead and open your lab up. You should launch the lab, start the timer. I think it gives you like 2 hours or something ridiculous. I think it gives you like 2 hours. By the way, Quick Labs usually gives you double, 2 to 3 times the amount of time you need to do the lab. This is a 60-minute lab. So we're probably not going to need all that time, right? So what you're going to do is you're going to launch the lab, and it's going to open up all this stuff on the left-hand side. Now, the reason it's going to do it so fast is that I pre-warmed the labs for you, meaning I ate the 10 or 20 minutes it took to kind of get these things up and running so that when you went to run them, they were already ready to go. You weren't sitting there waiting for it to provision infrastructure. Please do not start and stop these labs casually. Once you hit start, stick with it, because you only get to run these labs 3 times. After that, you're going to lose access. So even though you have 3 months of access, you only have 3 times of running these labs. So we're going to run them once in our setup, and that's going to give you 2 more times after you leave here to run these labs if you want to. Okay. Now, once you've got this going, All the instructions that you need are right here on this webpage. It's going to take 60 minutes. Services that are not used in the lab are disabled. You're going to start the lab. You're going to log in using this student, this password, and this account. And then you're going to launch your instance, and it's going to walk you step by step. Please, by the way, do not use the new console. AWS just launched a new console. Please do not use that just yet, right? And then you're going to launch your notebook. Make sure that you do every single line. If it says 8, 9, 10, make sure you do it. And then from there, you're going to just explore your Python cheat sheet. You're going to explore all the different pieces. And then you're going to review and complete the provided exercise notebook, right? So lab1.ipymb, you're going to run through that just as an exercise to get you familiar with Jupyter Notebooks. Okay, so at this point, who is not logged into webh.quicklabs.com? Good. Okay. This is what we're doing for the next hour. We're also going to throw in a break in here. So we're probably going to be doing this for pretty close till 4 o'clock, honestly. Okay. So I want you to work on this for the next 45 minutes to an hour. Squeeze in a 15-minute break in there. We're going to, just to make giggles, we're going to check back in probably just a little bit before 4 o'clock. I'm not going anywhere. So I'm going to be here to answer questions until I go take a break, which will probably be an hour from now. Okay. So otherwise, just keep going.